On April 6, 2026, Reed Wiseman sat inside the Orion spacecraft and said something no commander is supposed to say. He said human minds should not go through what theirs had just gone through. He also called it a gift. Those two statements should not fit together, but at 252,000 miles from Earth, they did. 4 astronauts had just traveled farther from this planet than any human being in recorded history, breaking a record that had stood for 56 years since Apollo 13's emergency flyby in 1970. At the moment the record broke, Earth was so far away that the light from it took nearly a second and a half to reach them, and the entire planet could be hidden behind a single outstretched thumb. NASA sent them out there to test hardware, to validate life support, to photograph the lunar far side with human eyes for the first time. But the most important data the Artemis II crew brought back had nothing to do with engineering. It had to do with what distance does to the human brain when you push it past every boundary it evolved inside of. And what they found has NASA questioning whether the next step is one we are psychologically built to take. Most people have heard of the overview effect. It is the cognitive shift astronauts report when they see Earth from space for the first time. That sudden awareness that borders are imaginary. The atmosphere is paper thin, and everything alive shares one fragile rock. Astronauts on the International Space Station describe it at 250 miles up, where Earth fills most of the window, and you can still make out highways, coastlines, and city lights at night. The overview effect at that altitude is powerful, but it is also comfortable. Earth is right there. You could almost reach it. Now multiply that distance by 1,000. At lunar distance, Earth does not fill the window anymore. It becomes a small, bright object, suspended in a darkness that has no edges. Neil Armstrong held up his thumb during Apollo 11, and it blotted out the entire planet. Jim Lovell did the same thing on Apollo 8, and he realized his thumb was covering every person who had ever lived. James Irwin watched it shrink from a globe to a marble on Apollo 15, and said it looked so fragile that if you touched it with a finger, it would crumble apart. That reaction is not the same overview effect the International Space Station crews report. Edgar Mitchell told researcher Frank White after Apollo 14 that the moon gives you a qualitatively different perspective than low orbit. Something more universal. Something that rearranges your understanding of where you fit. The distance does not just change what you see, it changes what your brain decides matters. The Artemis II crew confirmed Mitchell was right. Christina Koch was asked to describe the entire journey in one word, and she chose humility. Jeremy Hansen said the view from the far side bent his mind. Victor Glover looked through the camera lens and could barely speak. These are not people who were moved by a pretty view. These are people whose sense of identity was being disassembled by distance itself. And the recalibration went deeper than personal awe. Frank Borman said from the moon in 1968 that raging nationalistic interests and famines and wars do not show from that distance. 58 years later, the Artemis II crew saw the same thing and felt the same collapse. Glover told the audience watching from Earth that they were on a spaceship too, one built to sustain life in the emptiness of the universe, and that the distance between them only made it clearer how connected they all were. He could cover the entire planet with his thumb, every border and every conflict and every person. And what he saw underneath was one world with no divisions visible at any magnification. Koch described Earth as visibly brighter than the moon from that distance, its reflected light sharper and more vivid, as though the planet itself was insisting on being noticed against the void. The further you travel from Earth, the more absurd the idea of separation becomes. That is not a philosophical opinion. That is what distance does to the brain at this scale, and every crew that has reached the moon has reported the same thing. But the overview effect, even the amplified lunar version, is the gentle part of what happened to the Artemis II crew. What came next was not gentle at all. As Orion swung behind the moon on Flight Day 6, Capcom Jenny Gibbons radioed one final message to the crew. She told them it was a privilege to witness them carrying the fire past our farthest reach. Then the signal dropped. The moon slid between the spacecraft and every antenna on Earth, and for approximately 40 minutes, 4 people had no communication link to anyone else alive. No relay satellite exists for crewed missions around the moon. The rock itself blocks every radio frequency. There is no workaround and no backup. When the moon is between you and Earth, you are severed from your species completely. When Michael Collins experienced this alone in the Apollo 11 command module in 1969, he described what he felt with a line that became one of the most quoted passages in astronaut literature. He said, if you took a count, the score would be 3 billion, plus 2 on the other side of the moon, and 1 plus God only knows what on his side. He compared it to sitting alone in a small boat in the middle of the Pacific Ocean on a pitch-black night, where the darkness is so total that your eyes stop trying to find an edge to it. Collins said the feeling was not fear or loneliness. He called it awareness, anticipation, and exultation. He said he liked it. The Artemis II crew had a different reaction. The moment communications dropped, Hansen pulled out maple cream cookies he had brought from Canada and passed them around the cabin. They floated in silence behind the moon, eating cookies, while Earth was gone from every window. Victor Glover took a moment to say a quiet prayer. And then Reed Wiseman looked out and watched the Earth reappear on the other side, its atmosphere glowing against the blackness, the terrain of the moon casting a shadow across its surface as it rose back into view. He described it as unbelievable. And then he said 4 words, and then it was gone. That line was not about the Earth disappearing. The Earth had already come back. He was describing the moment itself, the fact that the most profound visual experience of his life lasted less than an hour, and he could already feel it slipping out of reach. The brain could not hold it. And what happened after the blackout ended is what nobody expected. The silence had cracked something open in all 4 of them, and what spilled out was not composure. Hansen admitted that even months later, recounting the experience made his palms sweat and gave him chills. Then Hansen looked at the lunar surface below and spelled out 7 letters: C-A-R-R-O-L-L. He was naming a crater after Wiseman's late wife, who died of cancer in 2020. The cabin went quiet in a different way than the blackout had been quiet. Wiseman's voice cracked. He said that when Hansen spelled Carol's name, that was when he was overwhelmed. The entire crew broke down together, 252,000 miles from the planet where Carol had lived and died. 40 minutes of silence had opened something in them that their training never accounted for. The emotional rupture did not happen during the blackout. It happened after, as if the brain needed the connection to return before it could process what losing it had meant. If this is your first time watching, consider subscribing. We break down the parts of space exploration that most channels leave out. While the crew's minds were processing 252,000 miles of distance, their bodies were processing something more mechanical. The moment you leave Earth's gravitational pull, your muscles begin to atrophy. Bones lose density at a rate of roughly 1 to 2% per month. Fluids shift upward toward the head because gravity is no longer pulling them down, which raises intracranial pressure and can affect vision. The cardiovascular system deconditions because the heart no longer has to pump against gravity. 10 days in space is enough to start every one of those processes. The Artemis II crew returned to Earth on day 10, having experienced the beginning of a physiological breakdown that, on a longer mission, becomes irreversible without constant intervention. Now, layer the psychological data on top of the physical. Wiseman said human minds should not go through what theirs went through, and then called it a true gift. That contradiction is the most honest description of what extreme distance does to cognition. The brain recognizes the experience as extraordinary and simultaneously rejects it as exceeding its operational range. Wiseman also said the real weight of the mission would not land until they were home, meaning the brain was deferring the full processing of 252,000 miles of distance because it could not handle it in real time. The mind was protecting itself from its own experience by postponing it. NASA already knew this would happen. The agency's own human research program uses a framework called RIDGE that identifies 5 standalone hazards of spaceflight: radiation, isolation, distance from Earth, gravity fields, and hostile environments. Distance from Earth is listed separately from isolation because it creates problems that confinement alone does not. You can simulate a small habitat. You can simulate communication delays. You cannot simulate looking out a window and watching your planet shrink to a point of light that becomes indistinguishable from the stars around it. And NASA's behavioral health risk ratings tell the rest of the story. For International Space Station missions, the psychological risk is rated controlled. For lunar missions like Artemis III, it is rated acceptable, the edge of what trained humans can manage. For Mars, the rating drops to a single word: unacceptable. That is not an outside assessment. That is NASA's own classification of what its missions will do to the human mind. The difference between the Moon and Mars is not just distance, although that distance is staggering. 140 million miles on average, compared to 252,000 miles. The difference is time and severance. A Mars crew would spend 6 to 9 months in transit, with communication delays reaching 24 minutes each way. Real-time conversation with anyone on Earth becomes physically impossible. In NASA's Mars 500 simulation, where 6 people spent 520 days in a sealed habitat with imposed communication delays, 4 of the 6 developed severe sleep disruption that researchers compared to animal hibernation patterns. Their bodies began shutting down non-essential wakefulness, as though the brain had decided that consciousness itself was no longer worth maintaining at full capacity. And that was on Earth, in a building in Moscow, where the participants knew they could walk out if something went wrong. Their brains responded to simulated distance by retreating inward, even though the real distance was 0. A crew in actual transit to Mars would have no such safety net. They cannot abort and come home. The distance becomes a locked door, and the door stays locked for years. On flight day 6, after the blackout ended, and the tears dried and the maple cookies were gone, Victor Glover looked back at Earth from the farthest point any human had ever reached and said something that was not meant for mission control. He said, "Hey babe, I love you from the moon." That single sentence, aimed at his wife across 252,000 miles of vacuum, contained everything the mission proved about the human brain at extreme distance. It reaches for connection the moment connection becomes impossible. It translates the incomprehensible into the most basic words it knows. And it does this because 252,000 miles is close enough to the edge that the brain still functions, still feels, still loves, even as it begins to buckle under the weight of where it is. The question no one at NASA will answer on the record is what happens when the distance doubles, and then doubles again, and then multiplies by 500, and the brain reaches for connection, and there is nothing close enough to reach back.